Hi, my name is Darlisha D'Ambert, and today I will be talking about the uses of MHC Tetramers, pretty much how they work, and also their applications too. So it's a little bit of information that I'll be talking about. This is for video 3D, exam 3D video discussion. So going on, TCRs, they recognize and bind to complexes composed of MHC molecules and specific peptides expressed on the surface of an antigen presenting cell. The MHC peptide monomers are bioattenuated and tetramized with streptavidin to maintain stable binding to various TCRs. So what this does, it enables the MHC peptide and tetramers to be used. Sorry for the video. It enables the MHC peptide and tetramers to be used as a detection tool for that. The MHC tetramers, they are labeled with fluorescent molecules, and there's I believe there's 4, and excuse me if I butcher these names. But the first one is phycoerythrin, also known as PE. The second one is allophycoxinin, and that's APC. And there's actually 3. So the last one is brilliant violet 421, also known as BV421. So these fluorescent molecules, what they do, their specific job is to allow the detection of antigen-specific T cells. And by doing that, they do this by the flow cytometers or fluorescent microscopy. So I know I've been saying a lot about tetramers. So tetramers, what they do, what they are, they consist of multiple bound MHC molecules. So in other words, the need for MHC tetramers, it comes from a high dissociation rate of MHC monomers. This can be difficult for monomers through their detection strategy. So going back to one of the fluorescent molecules I talked about, which is the MHC peptide monomers that were bioattenuated and tetramized, that molecule streptavidin. I'm going to talk a little bit about that. Streptavidin is the centerpiece of a tetramer. I kind of look at it as the nucleus, so this is kind of like the main source. It's a molecule that forms homotetramer complexes. However, they're part of the MHC that can be replaced by covalently bound biotin. MHC molecules, they have a chance to be mixed with antigen peptides, specific antigen peptides of that interest. So it results into a peptide MHC complex. Bioattenuated domain allows up to 4 peptide MHCs to bind to a fluorescent streptavidin complex within an affinity. The tetramers, they bind to T cells that are specific for both the MHC type and peptide being used in the tetramers. So whatever T cells that are specific to the tetramers, whatever specific, I guess you'll say, job that those tetramers have, you'll see a binding between the two, and they will both end up into an MHC. So bound tetramers, what will happen to them, they will have stained T cells with other fluorescent molecules, and they will experience a removal of non-bound tetramers and ligands. So the stain sample that I just talked about, from the binding of the tetramers from the T cells with the fluorescent molecules, those stain samples will go through a flow of cytometer. So what this does, it just pretty much does a detection and a sorting of the two of those, what's going on. So it kind of sorts out what each specific thing has. The fluorophore gives signal to the bound tetramers, and it indicates that the tetramers are bound to T cells of its specific peptide antigen. And what this signal does in result, it just gives an existence of a cell mediated response.